Hello students, today we are solving a question from units and measurements. This is from 22nd January shift 1, JEE Mains 2026. The question has list 1 and list 2, two lists, and we need to match the entries in list 1 with the entries in list 2. So let's begin matching them. You can pause and see what are the quantities. I will begin. So first quantity is spring constant. So we know as soon as we get spring constant, we should remember the equation F is equal to Kx. So K will be equal to F by X. So spring constant's dimension will be dimension of force by dimension of distance. Dimension of force, everybody should remember, it should be m power 1, L power 1, T power minus 2 divided by L power 1. So basically, the dimension of spring constant will be m power 1, L power 0, T power minus 2. So spring constant matches with the second dimensions. The thermal conductivity is the next one. So thermal conductivity, recall the law of thermal conduction. The rate of heat flow dq by dt is equal to Ka delta T divided by L. Here we need to find the dimensions of K. So you should remember dq by dt has the dimensions of power. So if you want the dimension of K, send everything else to the LHS. So dimensions of K will be dimensions of power into dimension of length divided by dimension of area into dimensions of temperature. Dimensions of power is m power 1, L power 2, T power minus 3, and dimension of length is L, dimension of area is L square, and dimension of temperature change is Kelvin. So putting these values, you're going to get dimensions of thermal conductivity is m power 1, L power 1, T power minus 3, K power minus 1. This matches with the fourth entry in the list 2. Next is Boltzmann constant. So recall law of equipartition of energy. Energy per degree of freedom will be equal to half kT. Now degree of freedom is dimensionless, it's a pure number. So energy itself is half kT. Okay. So the dimension of K will be dimension of energy divided by dimension of temperature. Dimension of energy is m power 1, L power 2, T power minus 2 divided by dimension of temperature is Kelvin. So this gives us m power 1, L power 2, T power minus 2, K power minus 1. So C in list 1 matches with the entry 1 in list 2. Finally, inductive reactance. Remember, voltage across inductor is current into inductive reactance. So inductive reactance has the dimension of voltage and current. Now voltage has the dimension of potential energy per unit charge, and current is a fundamental quantity. So its dimension is A power 1. So dimension of potential energy is the same as work, m power 1, L power 2, T power minus 2. Dimension of charge is current into time. So A power 1, T power 1. So final calculation will lead you to m power 1, L power 2, T power minus 3, A power minus 2, which is matching with entry 3 in list 2. So option 1 will be correct. Okay.